Hello again, Tom from Every Step Physics, EveryStepCalculus.com. A physics problem regarding vertical spring. You can see the problem on the screen and how my programs work with this. Okay, notice it asks for several different answers to this problem. Okay, when you see any problem in physics, you look for the variables. Okay, this gives you, and you write them to the side of your paper so you're not confused. Put M equals 0.5 kilograms, okay, over here. Next you look at the next variable. What does it say? Well, it's lowered to equilibrium position. This stretches the spring, okay? You have to know something about springs and learn something about them. I can't just do everything for you. And of course the most important thing is the stretch in springs, okay? And simple harmonic motion is what they usually are into when they're teaching springs, but the stretch is because of a vertical spring with the mass hanging on it, and its gravity is going to pull that mass down, and it's going to stretch the spring a certain amount, which just happens to be 10 centimeters here. Because it's pulling down, that's y, in the y-axis, okay? So you'd put on the side here, y equals 10 centimeters, okay? You go to the next variable. The body is then pulled down further from the equilibrium point, again, 5 centimeters. So you got the stretch because of the weight of the mass here, right? And then you're going to pull down 5 more centimeters and release it. And so the mass is going to bounce up and down with what's called simple harmonic motion, okay? And it would do it for an enormously long time if you were in the space shuttle doing this experiment, okay? So it bounces up and down, and then we have several calculations as to what's happening there. So you have, and that's called amplitude. When you pull something down further from equilibrium point, it's called amplitude. A lot of books and teachers don't say that, but that's important. It's called amplitude, okay? And so you're going to write A equals 5 centimeters on the paper. So you got 3 variables, mass, y, and A. Okay, generally capital A is for amplitude. So we're going to choose physics in my menu. You open up your titanium calculator and you get physics in here. You can buy these at my site, www.everystepphysics.com, $30, and you can buy 350 programs, which I send to you in the email, and you load them into your calculator, all with instructions, and you can do all these physics problems because of that, okay? Throw your physics book in the garbage, burn it, whatever, it's worthless to you, you know. Now, let alone, 2 months later or the rest of your life later. But these programs will answer this stuff for the rest of your life, for your kids, grandkids, partners, lovers, whatever, okay? If they happen to go to school or happen to want to know about this stuff. All right, we're going to get to springs now because it's a spring problem, so I'm going to scroll up to get to the bottom of the menu simply because S is closer to the bottom of a menu than it is to the top. So to save time, we're going to scroll to the bottom of the menu and choose springs, which I'm done right there. There's springs next to sprockets. Spring calculations. We're going to choose number 1, vertical. And we're going to choose what's given. And we're going to look for mass, y. Here's mass in the first character. We got y, and here's mass, y, and A, amplitude, okay? I'm going to choose that. You have to get used to my programs. You have to study them a little bit to see what's in the menus and stuff, If you have any other ways of doing this, let me know. I'll change it. This is the only way I know how to do it. Make it simpler for you to pass physics. So we have to press we're going to enter the variables. You have to press alpha first, okay? Alpha, that's just in my programs to enter stuff in this entry lines here. It's 0.5 kilograms, okay? Now we're at the stretch, vertical stretch, okay? And that's going to be alpha 10 centimeters, number 2. I do the conversions for you. Physics in college is more like doing algebra and tricks in conversions than it is about learning physics, okay? Professors love to trick you and see if they can trick you up on any math problem or anything. Ooh, centimeters or whatever. That all has to be changed to meters, etc. Now we're going to add, enter the amplitude, which you've written down in your paper off to the side here. 5 centimeters. Alpha 5 centimeters, number 2, okay? Do the conversion, write that conversion on your problem. You get 1 point or 2 for the test or homework. Remember, everything's scored in physics and calculus on the class curve, and you get points for every little thing you put on the paper because it's so difficult, okay? So I gave you the chance to change it in case you made a mistake, but I say it's okay. And now we're going to do the calculations, okay? I show you that the stretch is 0.1 meters, right? Right here, 10 centimeters, it's 0.1 meters. Okay, so now K is the spring constant. You write this all in your paper. mg divided by y, 49 Newton meters. Period is this right here, 2 pi times the square root of m divided by k. And incidentally, the square root of m divided by k, you're multiplying that times that. You notice that really the formula is 2 pi divided by the angular frequency, which is omega, which is k divided by m, but it reverses when you do algebra. When you bring something from the denominator to the numerator, it reverses these two portions inside the square root. That's where that comes from. That took me about several hours to figure that out. And frequency then is 1 over t equals that. Potential energy of the spring, kinetic energy of the spring, and we have the velocity at equilibrium is 0.49 meters per second. We want to see the answers again, so we're going to look at these answers again.